Welcome to solverfy.
Okay, so in this question, we definitely know it's not D200, and there's a very good reason why, even though that seems at first to be logical. So remember, we're starting with a 3-gram sample of sodium bicarbonate. Okay, and that we're given the molecular weight of sodium carbonate as being 106, right? So if we say moles per gram, we used a molecular weight of sodium carbonate. We know there's 1 mole for every 106 grams, right? So that gives us 3 divided by 106. It's going to be 0.0283 moles of our sodium carbonate. So it's actually sodium carbonate, not sodium bicarbonate. Okay. That's all well and good. And we know that this amount of solution makes 600 cubic centimeters of CO2. But the problem is that this is not the limiting reagent, so we can't relate grams of sodium carbonate to CO2. The limiting reagent is actually our HCl solution, right? So we have 50 cubic centimeters of HCl. We're told that the molarity is, it's given to us in cubic decimeters. So we need to convert cubic centimeters into cubic decimeters. So if we put centimeters down here, decimeters up here, we know that there are 10 centimeters for every 1 decimeter, right? This is a 100th of a meter, this is a 10th of a meter. And because we have centimeters cubed, we have to cube this whole thing. Okay, so now we have decimeters of HCl, and the molarity is simply 1 mole for every decimeter cubed, right? But then recall that in our reaction, we have sodium carbonate plus 2 HCl, right? So the actual ratio between sodium carbonate and our HCl solution is 2:1, 2 HCl's for every 1 carbonate. So if we want to find out how many moles of sodium bicarbonate this can react with, we need to go 2 moles down here of HCl for every 1 mole of sodium carbonate. Okay. So from that, we would get the answer. Well, we need to do math off to the side. 50 divided by 10 cubed, or 1,000. And then all of that divided by 2. And we get 0.025 mole of sodium carbonate. That is to say that we didn't have all 0.0283 moles of our sodium carbonate reacting. We had 0.025 moles of sodium carbonate reacting. So for every 0.025 moles of carbonate that react, we get 600 centimeters cubed of CO2. Okay, so that's the ratio that we have, is 0.025 moles sodium carbonate equals 600 centimeters cubed of CO2. Okay, now in the second, to answer the actual question, what happens when you use 1 gram instead of 3 grams? Note that we're still using the exact same amount of HCl. We're still using 50 centimeters cubed, and it's the same molarity, which means that the number of moles of HCl we have is the same as it was the first time around. It's 0.025 moles. Okay, so or the number of moles of sodium bicarbonate that could react with our HCl before we run out of HCl is 0.025 moles, right? Which means HCl is not the limiting reagent the second time around. It was the first time around, but it's not the first time. HCl, not the limiting reagent. In our second reaction. we'll have plenty of HCl. We'll have 0.05 moles of it, which is more than enough to react in a 2-to-1 ratio with the amount of sodium carbonate we'll have, because instead of having 3 grams of it, we'll have 1 gram. So how many moles of sodium carbonate will we have? We'll have 1.0 grams of sodium carbonate, right? And the molecular weight won't change, right? So we're going to put 106 grams down here for every 1 mole. Grams cancel, we get moles. And we're going to get a third of whatever we got the first time around, but that'll come out to be 0.0094 4 moles. No, that should be a 3. Sorry. Okay. Right. So if we have, as we said, enough HCl to react with 0.025 moles of sodium carbonate, then we know we have more than enough HCl to react with 0.0943 moles, right? So sodium carbonate is now our limiting reagent. All right. Well, all we then have to do is say, well, how many moles of sodium carbonate do we have? We know that. And then convert that into centimeters cubed of CO2. And we have the factor we need right here. This equality is where we get our correct ratio, or the factor that we can multiply this by. We say 0.00943 moles Na2CO3. We turn this equality into a factor by dividing both sides by 0.025 moles of sodium carbonate. So we get 600 centimeters cubed CO2 up top, and down below is where we put our 0.025 moles Na2CO3, or sodium carbonate. And what do we get out from here? Let's do the math. Take that number, divide it by 0.025, multiply it by 600. And we do get slightly more than 200. We get 226.42, right, which we can round using sig figs to 226. So the reason why the answer isn't simply 1/3 of 600 is that the first time around, it would be 1/3 of 600 if sodium had been our limiting reagent, but it wasn't, right? The first time around, the HCl was the limiting reagent. So we needed to figure out how many moles of sodium carbonate actually reacted, 0.028, which was 0.025. And then once we knew that, we could figure out what the ratio between moles of sodium carbonate and centimeters cubed of CO2 was. And with that factor, and knowing the second time around that HCl is not our limiting reagent, we basically converted grams into moles, and then used our grams of sodium carbonate into moles of sodium carbonate, and then used that moles of sodium carbonate along with the factor we developed to determine how many centimeters cubed CO2 we should get out at the end.